Welcome back, everyone, and welcome to our wonderful guests. The thing that's on my mind today is that change is inevitable. And the question for all of us here is, what are you going to do when it comes for you? Luckily, we have here on our panel some of the brightest minds in our industry to help us navigate change in our organizations and turn disruption into opportunity. So on our panel today, we have Kelsey Hightower returning from this morning. If you missed this or you've been living under a rock, Kelsey is a distinguished software engineer, developer advocate, renowned for his contributions to Kubernetes, open source software, and cloud computing that have empowered developers worldwide. Welcome, Kelsey. Here we have Hussein Nasser, accomplished software engineer, popular host of the Backend Engineering Show on YouTube, sharing deep expertise in backend technologies, databases, and network protocols to help developers build robust and scalable systems. Welcome, Hussein.
Good to be here.
And from the HAProxy team, you saw them this morning, Andjelko Iharos, VP Architecture of HAProxy Technologies, a leading expert in large-scale systems and the mastermind behind HAProxy Fusion. And Baptiste Assmann, Director of Product Management at HAProxy Tech, a specialist in high-performance architectures, and now HAProxy's product visionary.
That's me.
Welcome. Now, one thing we've definitely seen so far today is how many architectures are changing to become more dynamic, more flexible, more scalable. And that changes a lot, but it certainly changes how teams are going to manage and observe their application traffic. Security's been on our mind. So my first question to the panel is, how is security changing as infrastructure becomes more dynamic? And Kelsey, perhaps we could start with you.
I don't think it changes because it's more dynamic. I think the impact from things being dynamic are much faster. So if I had to check in code and then write it to a file and restart the process in order for it to pick up, for many people from the outside, it was already dynamic. The fact that you can even change it is where the dynamic part comes in. I think the implementation detail is where you get the consistency from. So before the dynamic thing, we just wrote a bunch of scripts, right? So you just wrote around it and then serialized to a file. I'm pretty sure a lot of people in the audience are used to configuration management tools, and we were just brute forcing all of this from the outside. I think now with the dynamic nature, at least the thing we're trying to configure understands what we're trying to do now. So instead of working around the software, we can work with it. So now you have an API for configuration. And so when I send the call to you, you do all the right checks. You do things in the right order. You can keep track of things that are in flight. So I would say in some ways, the automation has gotten easier because the intent is a little bit one-to-one now. And I think from a security standpoint, security as a practice stays the same in my opinion. Are you sending the right values in the configuration? And then how do you know when they're not? That remains the same. I think that's a fundamental thing that just doesn't change because of the implementation of automation.
I agree. I think one of the things that's changed in the sense of becoming more important is observability. Because of the dynamic nature of either the infrastructure changing or the incoming threats being different or adapting to any mitigations already in place, being able to observe the impact of any future or upcoming, right now implemented configuration changes is, I think, much more important because we need to change it so often and we need to adapt to the situation much more quickly. Before, when we used to have an environment under duress, we would reconfigure some protection policies and we would probably be fine, right? But now the environment can maybe scale in response to increased load. And then all our protections need to be aware of what happened with the infrastructure changing so that we either further accommodate the more backend servers that we have or less resources that we have on the load balancers because now they need to handle more connections or things like that. So that observability to be able to not only react to the environment or the conditions, but also see the effect. I think that's kind of even more important these days.
We're gonna be a little bit more spicy. We're not gonna be the corporate one question at a time thing, right? Great. So look, I don't know if it's observability actually. Like in 2010 when Puppet came out, like configuration management tools, most people don't even know what they're looking at. So we had logs.
Right.
But if you don't know what you're looking at, you're not gonna do anything. If you have observability, you can have all the metrics you want. If you know what you're looking at, it just doesn't matter. I think the declarative nature of saying, I would like these 27 backends to be an HAProxy. So that's an intent. And so the way we do it in a dynamic world where we don't know all the servers ahead of time, we would say, I would like every app with this label, key equals value, and anything with that label, I would like to be an HAProxy. So that declarative nature says, that's all I want in HAProxy. And I think what you mean by observability is, how do I know when that's not true? So if I go to HAProxy and you're sending traffic to things without that label, we have a problem. So how do I tell you that? And I think that's the linchpin for the security policy. So now, I think in the dynamic world, it isn't watching dashboards and say, oh, there's 71 backends in here. It's like, how do you know it's supposed to be 71 or 70? You have no idea. What I want to know is, but does it match my policy? Anything with these labels should be there, and auto-scaling can do whatever it wants as long as I have policy and control and a declarative intent. Those two things, I think, combine into a world that can be audited. And then when you do observability, you actually know what you're looking at, because when it turns red, it will point to the policy as the reason.
That's a good take.
Well, I mean, at the origin of any security issue, there is a human. So
You don't know any of what?
there is a human.
Human.
Somebody doing something wrong, forgetting to configure something, opening a port, not closing it, etc., etc. So the biggest problem with security is clearly people. And so as long as they are not taking care of what they are doing, you will always have security problems. Even the biggest company, banks, etc., they can do whatever they want. There is always one way to get in.
Well, remember, people could also include the vendor writing code in a way that I did everything right, but the vendor did something wrong.
Yep.
And you are the reason why I have this buffer overflow.
Right. It can be omission rather than like it can be a combination of circumstances rather a single person, right? An out-of-date specification somewhere, a port that's not updated in some configuration. So I agree, but it's I guess there's a lot of nuance to it as well.
I would add to that probably all the scripts and the configuration that we author comes from us, human, right, at the end of the day. And mistakes will eventually happen, right? We can blame AI and the machines all we want, but eventually a human have configured these things and wrote the scripts to do that. I'm reminded, these discussions remind me of an outage that happened in Amazon in 2021 in the midst of the pandemic. What happened was Amazon AWS went down for, I think, 21 hours. And I covered that on my show and on YouTube back then. What really happened was an engineer has configured a policy that says, well, since we're getting a lot of load during the pandemic, let's increase the auto-scaling policy. And they put a number, I don't remember, it was like 20%. So that load has been met. And what happened is the auto-scaling policy is scaled and spin up, interestingly, 1,000 more backends than anticipated. And for that, you might say, okay, that's nice, or 1,000 backends, now we can have more instances to consume our request. But if you think about it, every backend that spins up, it's a cold start. And in that particular thing, if we want to define what that means, is I need to read my configuration as a backend. And in Amazon, specifically in that particular case, and this is all written in their root cause analysis, where they were querying a database. And that database was a single instance because they think, this is a really simple configuration, in and out, I'm going to query. I don't need another instance of that database, right? You can think about it, so you always sometimes need more. But in that particular case, that herd of backend started initiating multiple queries to read the config, to read the configuration, and then it puts a load in the database. There was a retry policy that says, if you couldn't get your configuration within 500 milliseconds, try again.
Try harder.
Try harder. And guess what? Right? And this is like a little bit controversial, but you'd think you cancel a request, but request is really almost never canceled because you can give up as a client, right? But the request is still processing in the database, right? So that request comes in, another request comes in, and then the database gets overloaded, and then eventually the entire backend infrastructure died. CloudWatch, as a result, which is the monitoring platform, which uses the same database, went down because the database went down, and the entire thing it was snowballed. And this whole thing reminded me back to the configuration and trust. And we can talk about trust when it comes to different communication between the cloud. I think I'd like to bring that as a next topic. What do you guys think?
But you're also describing how far away configuration is from the actual real state of the world.
Right.
I want to scale this by 20%.
Yes.
That's what I want. But what the rest of the system does is not articulated in that statement.
Absolutely.
And that's the nature of reality, right? So that's the practice. And I get back to but we don't have a lot of tools that say, the thing that you just asked for caused these problems. So would you like to undo that? The correlation isn't there. Like when Kubernetes came out, the whole system is designed from this declarative interface the whole way through. And so when you ask for something and the system cannot do it, it'd say, hey, there is not enough memory here to deploy all these things, so I cannot do it. And then you can go decide whether to remove that request or the system just says, I will just sit in this loop forever. Most of our systems aren't designed as a collective whole where they feed back into each other.
Right. What would add to that is, I'm sorry, but what would add to that is like even defining what a problem is. The system doesn't know what a problem is. We do as a human, right? Because we think as like, okay, doing a lot of requests at the same time is a problem because limited memory, limited CPU. That needs to be defined in the policy as well. Don't exceed this much. And I think there is unlimited number of configuration that you put in to kind of box yourself.
What do you do when there's a problem? I think that's the other part of it. You can't know everything.
Yeah, exactly.
So in the case of a problem, it's like, hey, I can't do this. What is the failure state when you don't know?
Yeah.
Right? Like, I don't know 500. It's not the best response, but at least I know that this is not what I wanted. And so there's like, either you fail open or you fail close. And I think a lot of these systems, they just say, well, I'm just going to keep trying forever. And who knows what state I'm in.
You guys raised the point that sometimes automation has unintended consequences.
Right.
It seems we're obviously under a lot of pressure to automate, to scale, but automations can either scale your solution or scale your problems. So how do we do automation right?
Well, it's in taking this example further, it's not about automation failing. It's about automation being incomplete or unaware of the entirety of the system. Because the automation worked on the service consuming the database, but not on the database itself. Or the automation was not aware of the database. Maybe that's a good separation of concerns. Like the database team worries about the database, the application team worries about the application. But there has to be some knowledge sharing, and when those policies are put in place, they either need to be put in place with the knowledge of the rest of the system or in coordination with the other teams to know that this database does not scale plus 20% randomly. It can go, there's an absolute limit there, or there need to be a wider scope of coordination where if the application scales, the database can scale as well. And in that case, it works as a whole system rather than as a loose collection of components?
I would say my answer is going to just be correlation. You're never going to get these things right. We're so far along. We're like, what, 40, 50 years into this thing? So depending on what database you're running, what proxy you're running, what programming language you're using, your network drivers, your Linux kernel, the libraries on the system, I don't even know if you can ever manage it perfectly. So I think the industry solution has been correlation. If there's a change being made, there's a timestamp somewhere. And then when errors start to generate, there's also a timestamp. And so that's a simple correlation. Someone made a change, and these errors started happening around the same time. The naive approach is that these must be correlated. And at least you have a starting point to try to figure out why everything else went crazy. And I think sometimes, like we see in HTTP world, there's that trace ID. I think that was like one of the biggest revolutions when microservices came out. If the proxy creates a trace ID from the very point, or even the client does it, and we pass that trace ID all the way through down the system. When I was at Google, we used to put that trace ID in the database call, right? So we know that some client way up the stack started kicking off a series of dominoes, and then the thing that's going to make the query to the database, you also use that trace ID as metadata, so that way when the execution plan or we're doing a full table scan and we didn't mean that, we know the trace ID of where this propagates to, because I think it's just so random. So I think the number one solution that we're trying to get to is just the ability to correlate these things. And I think that's the foundations of what observability is meant to be, that we may not have an answer to all these problems, but boy, if we can correlate them, we go from like hours or days of troubleshooting to at least something that says, start here if you want to find out what the root cause is.
You know, that's what I explain usually, how I explain the power of HAProxy observability, just to come back to HAProxy a bit on this topic, but that's exactly it. We don't know where the problem is, but you look at the logs. HAProxy can log up to 11 timers per request, can log you the termination state, etc. And so we don't know what's happening, but we can tell you that whenever this client is calling this particular URL, it takes 10 seconds. But when this URL is probed from this server, it's only 10 milliseconds. So maybe the problem is on the server itself and stuff like that. And people like it because usually they say, you know, when you have a problem, you have to troubleshoot. It's like, I don't know, 1 hour, and 50 minutes is finding the source, and 10 minutes is fixing. And if you can reduce the troubleshooting part, then that's a win-win for everyone. And that's my favorite feature of HAProxy, basically.
Now, this being 2025, of course, any discussion has to talk about AI, LLMs. We've had a little bit of mention of this earlier on. We've seen people, routing traffic to multiple LLM backends. We've got people trying to integrate with MCP. So what sort of challenges and strategies are you seeing with these technologies, in particular with regards to the management of the traffic flows and automation of configuration?
I mean, we're back at it again. So 20 years ago, we used to have the same discussion about databases. Queries are so expensive. There's not a lot of memory on the server, not a lot of storage. Every complex query that makes it to the database is expensive. And then people's like, there's this magical technology called a cache. You would check that query to see if it's been run before. You go to the cache, you pull the result out, and you give it to the client instead of taxing the database. I think the current state, and it will get better, the current state of doing inference on infrastructure is so expensive. It's almost one of the most expensive computational workloads we have today. And so if you think that you're going to use the same load balancing technology just to send random requests, we're so spoiled now that there's so much memory and general CPUs are doing such a good thing. We have instructions like AVX 512 that makes a lot of things super fast that most people just say, scale generic servers out, it will be fine. You ain't auto-scaling $80,000 GPUs. Hell, you can't even buy all the ones you want to buy at the moment. So now we're faced with the same challenge again. We have a very expensive workload that you cannot just blindly send traffic to it. And you're going to have to get way more intimate with the low-level details of where's this thing preloaded? Do we cache this response? And I think we're just back full circle. Different workload for sure. I know it's AI, but I think from the networking perspective, it's the same thing. If there's an expensive backend, you need to think about caches or other mitigation properties until that becomes so efficient that you don't have to think about it.
Yeah, and since it's like it's almost like the new discovery period again for the tech world, and this is it's so far it's still realizing its potential, but it's on track to like be a significant enough contributor in an unknown number of use cases where we need to consider it, but we don't know the extent of the change or impact it's going to have. So our application developers, they're figuring things out. They're throwing MCP servers left and right. We started off with the Standardizing MCP servers. Now they're over the network, right? These like the list of MCP servers today is like it's roughly mapping to API calls. It's exposing regular services that we already know and love, like databases or like hosted APIs and so on, to our LLMs. But I think that's probably only the first wave of integration that we're going to have. Likely, we're going to have more as these LLMs grow in capability, which it seems like they're still going to keep growing a little bit. There's chances our application developers are going to come up with even new ways and more ways to like utilize this technology. And in what way we're going to have to like consider that and protect them or load balance them. We're going to have to keep adapting and keep a really close eye on how the things are evolving, because I think we're still in the like uptake phase of it.
Yeah, from a product standpoint, I mean, I had a look at this because we saw that the emergence of some AI gateway. But in the end, when you want an AI gateway, what do you need? You need caching, you need rate limiting, you need authentication, that's HTTP, that's API gateway. In the end, that's nothing magic. So yes, maybe they are going to reinvent the wheel. The only difference is that when you have an API call, you can analyze the payload, and you don't really care. That's easy. When you have an AI call, you have to understand the prompt. Because you can't, two people can send different prompts, but each of them could bring the same response. So that maybe you want to use a cache. But you can't do that with HAProxy today. So if that's different prompts, for us it's different requests. So I guess it all depends on the type of use cases for LLM and MCP and stuff like that. I guess when it's an agent talking to an MCP, it will be easier because each agent will generate the same request, and so the prompt can be cached easily and the answer can be cached, etc. But yeah, no, that's definitely a new exploration for us, product-wise and protocol-wise.
The way I kind of understood the question was, today we have this technology that's AI. Well, we had AI before, but today it's a learning model. There is existing thing, this technology, it can predict the next word. That's how I look at it. And I think it fits perfectly to, I have a proxy, I have a load balancer, and I have a bunch of logs of all the requests that have passed and all the responses that came back from the backend. So you have this rich data sets that you can, not in real time necessarily, but every week, here's what happened, right? Here's everything what happened. You can ask questions given that data set to the language model and says, what is the trend? Then you can ask a prompt and say, all right, what is the most expensive queries or requests? And why are they, especially what is the trend? Like why is this particular request became more expensive than the other ones? And it can find interesting patterns that we might have missed or not easily calculated based on existing monitoring tools. That's how I look at it. I don't know.
Have you run any interesting experiments with AI that you'd like to share, and what challenges you've run into?
I don't know. I mean, I use AI for things that I forget, like how to do TCP dump and what is the parameter for the port, because I keep forgetting what's that, right? Things like that, like how do I filter based on interface? Is it -i or -i? Things like that. That's how I use AI, in my opinion. Like very basic things. I don't really, and that like instead of Googling, I would ask the AI for that. But sometimes even that gets it wrong.
I think one unique thing here is why are we using the LLM to begin with?
Right.
If you use an LLM to try to build a deterministic system, I don't understand why you're doing that. For example, in computing, typically, when you calculate an answer that is the authoritative answer to the question, you don't calculate it again for the sake of efficiency, right? Like when you build software, you compile it once, you create a binary, and you distribute it 1,000,000 times, and you auto-scale that. We don't auto-scale make files, and then when a request comes in, we build the app first and then respond. That's insane, you would laugh. So when it comes to like an LLM, its dynamic properties is one of the most valuable components of it. So I'm getting an unknown input, like I want to translate something, but I don't want to limit the input. So you can say whatever you want, and I'm going to send it to the LLM to be able to attempt to answer this question. That's the beauty of this particular technique. I think when it comes to the networking layer, we're dealing with a workload that, for the first time, we seem to be okay with it being non-deterministic. So yes, if we get the exact same prompt, we probably want to be able to cache and retrieve the same answer. But at some point, you're never going to send everything to an LLM, like for a knowledge base. You're probably still better off computing the knowledge base as a graph and then using search techniques, even if it's an LLM prompt, because it's just more efficient. So I think this is the new set of challenges that some people want a pure pass-through, and some people do want that dynamic lookup, but there's way more negotiation that has to happen on the back end. Is the model loaded? Does the GPU have resources? What's the response time looking like? But again, I just zoom all the way out and says, to me, this doesn't look any different than any other type of workload. Where you can say it's AI, but you're still probably moving the same bits and bytes across the network. You just have different concerns in which you do it. And the same vocabulary tends to apply.
That's an interesting point of view so I guess you're using the nice UIs they provide you to ask your questions.
Or APIs or whatever,
that's the point.
SDKs.
That's the point. SDK, I don't know, but I discovered, I think it was Gemini or Mistral, that's a French one, so I'm advertising for them. But when you use their UI or web front, you just have one prompt, and that's all. You don't have any settings. And I said, okay, but I wanted to make a page in HAProxy to call an AI, just for fun. And I discovered I have a nice API where I can change the temperature, and I have literally 100 of parameters. I said, wow, that's how I want to use the AI. I don't care their UI where you can't choose what you want. And definitely the first thing I said is temperature 0. I mean, I want to have predictable response. I don't want you to, when I'm asking you, I don't want you to hallucinate on stuff and things like that. So that maybe I'm not the right user for the AI.
It's not, so for you, you want a predictable response, but I have 100 million customers, and they all want something different. And we're beyond the ability to do if statements. If it's you, give you this response, that's over with. This new paradigm says we're going to go away from symbolic programming techniques, and we're going to allow the unpredictable. Now, we may put constraints. We may try to limit what it says, but the absolute value is its generative properties. And those happen to be somewhat unpredictable across your entire customer base. So the net new thing here would be, how would observability get used in this context? So instead of just capturing the request or the request and the response, they need to be correlated again. Yeah. Why did you give this user? Well, the context was different. They were located in this particular country. The alignment parameters say they were not allowed to give those responses for political reasons. And this is why collectively it got that request response in this scenario. So it maybe amplifies the need for even more correlation so you can understand how the system is behaving.
But the MCP throws even more complexity into the mix because the same prompt against the same LLM, when calling an MCP tool, the tool is an external thing to the LLM. And the tool is going to run an API call, or it's going to run a database query. And between one and the next prompt, the database query might return different results. The API call might return different results. So therefore, the LLM response is going to be modified by the contribution from the MCP tool call.
Let's be clear here. The MCP is going to return a predictable response here. So this is the part about calling it MCP. It's an API.
Yeah.
with a predictable protocol for the calling side. It's not a net new technology. If you look at most code for MCP server, it's using the same client libraries as before, calling the same database, calling the same Salesforce. If you call Salesforce with the client library, it's going to do the same, whether it's an LLM calling it or you call it by yourself via curl. So we know everything from MCP back to the other side is deterministic.
Yep.
It guaranteed us. Let's not pretend we're talking about a whole new paradigm. What's new here is the agent. The agent is unpredictable. It may call all of your MCP backends when it should only call one.
Yep.
Like that's a new thing you're gonna open yourself up to. The other thing we haven't learned how to do is scoped permissions. If I'm a user and I go to a prompt and I say, delete all the users from the database. Well, some people still don't understand the fundamentals. So what they do is they've configured their MCP agents with root God tokens that can do anything. So if the prompt makes it to the MPC server, it has no idea on who's acting on behalf of. Why? Because if you read the protocol, there's nothing about permissions.
Yep.
There's nothing about headers. There's nothing about exchange and scope tokens we've been doing for 20 years. So people are starting to make the same mistakes because they forgot the fundamentals. We know how to make calls on behalf of other users. We do it in every SaaS product today. So I think the fact that we say MCP as if it's some new magical construct, it is not.
So you see, you come back to my point, human errors.
What's that?
Human errors.
Human error.
Once again.
Yes.
And new application developers are going to start enabling the MCP protocol, but this gives us an opportunity to, if we proxy all the MCP calls, we get a known protocol with built-in discovery, because that's how LLMs discover what tool calls they have available, just by getting a listing of all the tools. And so we can build in observability, and we can generate ACLs from that. We can generate an RBAC from getting a listing from the backend server.
I mean, the low-hanging fruit for you guys is that you have a gift.
Yeah.
You're looking at this thing as like, in 10 years, they're going to discover everything you've learned 20 years ago. And until then, customers are going to have to put something mature. And there's this saying, like, make the new thing work the old way.
Yeah.
That's what tends to happen with these new technologies. I watched it happen to Kubernetes. We added NFS. We added static IP addresses. We went and added all the things that we said were not cloud native because it's reality. MCP, if you're smart, you're probably going to put a real mature proxy so you can deal with malformed HTTP requests. That's still a thing. There's TLS bugs and errors that will cost you your entire business. That's still a thing. And there's things like authorization.
Exactly.
That's still a thing. So MCP is the biggest gift to the proxy community in about a decade because everyone's excited. And if you try to use it as is, you're going to be on the news for the wrong reasons.
For the wrong reason, exactly.
And we will need a firewall for that. Web application or MCP firewall kind of thing, definitely. Let's do marketing.
You can charge more money. It's like, oh, this is MCP firewall.
Yes.
Oh, I don't know what that is.
Good idea, yeah.
For sure. And
You're gonna pay.
No, but it also it does bring value because every application that delivers an MCP server has a different set of configuring the rules, permissions, users,
And just say the same thing. Every API, the same statement is true.
Yeah. But the MCP protocol kind of
It sucks,
homogenizes
and it needs help.
Yeah,
And you're here to help it.
And we're
That's
here.
it. Say it plainly.
Exactly. It homogenizes the API calls from like the different databases, the different APIs into the MCP protocol. So now we're no longer dealing with the query strings in one URL for the one database and then JSON bodies in the other one. It's all homogenized to the MCP protocol. So we can know what to expect. And instead of trying to fight each of your application developer groups or each of your application developers, you need to check whether or not you're generating your API keys with limited permissions or with root permissions or whatever. We can bring that into the load balancer and we can make checks there and say you're trying to post to these are the MCP servers your backend servers are exposing. You can limit access on them. You can prevent making calls through them. Or we can even authorize different LLMs differently and like allow some of them to make more calls, allow others to make less calls. So there's a lot of playroom I think we can expose.
The thing that I like that's new, before MCP came out, I think we kind of hit a limit with like JSON schema, where we just described the inputs and the outputs, and we kind of stopped. And there was a whole movement around things like Backstage, because no one knows what these API does. The docs tend to be not that great. You have a discovery problem to figure out what's even available.
Yeah.
And when you look at the MCP kind of protocol, what makes it really unique, there's a concept of a catalog. What is available? And then there's this really simple description. What should this thing do?
Yeah.
Like humans could even benefit from that. You can imagine just doing an LS on what calls are available, an example of input, an example output, a description on how to use it. Even someone using curl could benefit from that. I can imagine a proxy could say, hey, based on this description, maybe we apply some security parameters even though no one configured them ahead of time. So I do think that's a net new benefit, but it's still networking.
It kind of back to the cycle, right? Whatever you just said, Kelsey, the catalog idea. This reminds me of SOAP with the WSDL, because you can query the endpoint. Says, okay, what do you have as a SOAP? The simple object access protocol.
SOAP ended the careers of a lot of people.
Indeed, it did. So yeah, everything comes back, I think.
True, but in this case, there's a positive feedback loop, because in order to make LLMs more effective at using the MCP tools exposed to them, the descriptions need to be better for the LLMs to understand them better. And the trick is the LLMs are understanding human language just as well as we are. So the application developers are motivated to make their MCP tool descriptions more descriptive, more to the point, to make their examples not just placeholders and just to-dos, but actual examples that reflect their actual real-world tool usage. Because if their examples are incomplete, if their examples are like out of date, those examples will propagate mistakes into the LLM tool calls. And some LLMs can work through the errors, other ones might not. Otherwise might make mistakes which were costly, which can be costly to make with those descriptions being out of date, with the examples not being correct. So it motivates the application developers to put more effort into the documentation side of the things. And ultimately, that benefits human users as well.
You know, it's crazy that 20 years, and there's a lot of developers in the audience is like, no, do you know how much documentation sucks? If I go there, you would benefit from everything you said. If you had good API docs with good examples, then developers would not call your API in the wrong way, respect the rate limits, check the headers, check the error body. And for some reason, we didn't do that for real intelligence. But maybe there's an incentive
we can do it for
the
the artificial one, right?
You guys have made the point that some things never change, that the shiny new thing is not fundamentally different from what came before.
Absolutely.
There's nothing better in motivating engineers to do more work than the promise of having to do less work sometime in the future. So if we can promise that, we're good.
You know, one day I applied to a job and I've been refused by HR because I said, I'm lazy, I'm making my computer do my job. She said, oh, no, not you. That's exactly it.
But here's what I'm curious about, guys. What are the things that have stayed the same and that drives you crazy? What are the things in this industry that you wish would change but haven't changed in 10, 20 years?
The best way to hide stuff from ignorant people is to write it down. The number of people who won't take the time to read about the thing that their craft is about, if you're a developer, you should read how your runtime works. You know, go to the language spec, read it once, take a few notes. How does it do memory management? Because when people don't do that, they show up and just brute force stuff and complain on the internet. This thing sucks because it's like, why are you running the JVM in desktop mode on the server? You spent $10 million in Amazon VMs because you want to run in desktop mode. That's a $10 million mistake, all because you didn't want to read the first 2 or 3 pages of how the JVM works. Those GC flags make a big, big difference. So if you're going to be in this craft, it's an engineering discipline, or it's supposed to be. And the number of times I just watch people not even try, like read the man page. If you don't like being mansplained to, make an alias to mom. You listen to your mom, You can call them mom pages.
Nice. Like
But you should at least try to understand how this stuff works at an intimate level. And it seems like most people just want to go straight to implementation details, right? You get the SDK, you import it, you just start calling stuff. And you're not realizing how expensive is that call? How much memory does that call add to the overall footprint of the app? Wow, you just downloaded the whole internet as the dependency, so you can translate 2 letters from left to right.
Do you have any programming language in mind with that?
All of them.
No. Oh, no.
All of them.
No.
All of them can have this. No programming language is immune to abuse. And it's like the gaps we see is when, typically, so to me, the whole, what is my responsibility in terms of documentation? When I learn something, the reason why I think a lot of developers get a lot of maybe following is that we explain things to people. Like, I think the people that are recognizable the most are the ones that take time to explain. If I show up to Slack and I say, hey, why isn't this working? That's a form of documentation. It doesn't have the reach of official documentation. This is why READMEs are so important. But that's one thing where I think documentation is still treated as somewhat as an afterthought in terms of like how much productivity it can bring to the general population.
But isn't this a business problem? People, management or sales or marketing, whoever, non-engineering departments just want things as soon as possible, as fast as possible. They don't care if the thing is efficient, works, or whatever. They just want it released tomorrow.
Yeah, but I care. So when I was working on Kubernetes, there was a lot of business reasons to just keep producing products. And I spent a whole 6 months to write Kubernetes the hard way. It was painstakingly a hard thing because I had to document everything all the way down to how to generate SSL certificates by hand and why Kubernetes reads SSL certificates that way. And I remember when we were in that room having the discussion, there was one group that just wanted to build automation tools just to make it a one-click deploy. But I thought if we build these tools and there's ever errors, we're going to be answering questions till the end of time, and our community will have no understanding. And there was another bet that I thought was appropriate to make. The more people who understood every nuance of Kubernetes, it will grow the number of creative people who could then contribute to Kubernetes in a way that an automation tool hides from them. So I think you're correct on the business part, but a lot of engineers have political pull. A lot of you all actually have some social capital that you can cash in. And there are many times in my career where I've chose to cash in on the documentation side, and it had industry-wide payoffs for time to come. So you got to make that call.
And I want to thank you for the Kubernetes the hard way. That's how I started. And then I knew you. No, that's interesting. And we were having this discussion sooner about using products, using software, using whatever. And back to your talk this morning about the fundamentals. Right. You have to understand exactly the protocols. And if you know the protocols, whether you're using HAProxy, Nginx, Varnish, whatever, HTTP is HTTP, a host header is a host header, an authentication, etc. An API is an API. That if you understand this, then you can adapt, you can understand things and make better things. And take your time as well. If your marketing team comes and say, okay, we need this tomorrow, you can, no. You can have it tomorrow. That's like you give me 1 hour to make a horse, to draw a horse, and then 1 minute, and then 10 seconds. You can have a horse, but one will be very beautiful, and the last one will be very ugly. It's up to you to choose. But there is engineering time to make things the right way.
One of the things that hasn't changed in 20 years is whenever I open a little bit of an older code base, searching for a bug fix or something, and I find like some crazy lines of code, and I think like, who is the crazy mofo that wrote this down, and why is there no comment?
Get blame.
And then get blame, right? And it's me. So why did I do that? Why did I not exercise more self-control and add those 2 lines of comment that would have meant the world to me and saved me 3 hours of racking my brains? That's one of the things that hasn't changed in 20 years, and I'm pretty sure for a lot of us is the same. So I think the journey of self-improvement is one that's still worth going on.
Stop delaying. Don't say, I will do it later. No, you will never.
Well, I hope all these productivity gains from the promises of this new tooling not just means we just create more mediocre stuff faster, but that we actually have time to step back and do some of these things that would require so much more time, right? Like the things that only a human could do.
Yeah.
Maybe we have more time to do it.
Yeah, I want to add to this concept of productivity, right? Today, with the rise of AI, we can do things easier. And I want to define what easy mean here. Easy is a single line of code instead of 5,000, right? But that single line of code, behind it, that 5,000 line of code, whatever you did, the complexity, if we want to call it complexity, didn't go away. We just abstracted it away. We just made it pretty. And that's why I feel engineers these days are, gravitating towards how can I be more quote unquote productive by, I have this line of code, let me copy and paste and it did the work. But behind it, as Kelsey said, there's so much behind the scene. It's making all these calls, it's doing many TCP connections because it's not using a connection pooling. All of this, to make it easy, you need to hide. And I think Baptiste mentioned that, right? When he mentioned about this UI with all this controls. He likes that stuff, right?
No, you
but you don't.
I want the CLI.
You like the simple thing.
JSON.
Yes. So instead of a single prompt, you've given all these parameters an option, and these configurations are where you start. That's why you have to go back and understand the fundamentals behind all of these new technologies, because abstractions eventually will leak. It will leak as a performance, 100% CPU usage, lack of memory, and that it may work today, but in the future, you will see these problems, and you will not be armed with the tools to protect you, but because you don't have the understanding of what's going on behind the scenes.
You're making a good point. I think the last 10 years-ish, we just built as an industry abstractions on top of abstractions on top of abstractions, and maybe another layer. And maybe that's something I would like to see disappear and get, as you said, back to the fundamentals.
To your question, yeah.
Exactly.
You guys have spoken a lot about the impact of human mistakes on security or the inevitable problems with MCP and agents, or with what you're just talking about, the things that you wish would change but haven't are largely human. How do you guys deal with your own personal development? Change is not just with the tech or our organizations, it's in us. So how do you manage change in yourself?
Man, I spent a long time. It was the core of my retirement. I said, hey, I spent a lot of time learning to get into tech. What language do I learn? What skills do I learn? Get in. Then I spent even more time trying to get promoted. But then there's an exit. And I think a part of that analysis was I was afraid of becoming a senior engineer, but a junior human. Like most people do not put this amount of effort into things outside of work, right? You're just trying to recover so you can go work again. And so when I think about all of these tools and why we do what we do, I think humans are just literally trying to make decisions. Like if you think about writing software, this saying is writing is thinking. So it's not the tedious part of just writing code and syntax for the sake of it. Typically you're thinking and making decisions. What protocol do I use? What endpoint do I call? How do I process this response? There's 10 fields that come back. I only need 2. These are all the decisions that you're making that goes into, in many ways, training your own model and understanding of the system. So when you write code, typically you're thinking and understanding the system. And so then when there is a problem, that person is trained. They have full context of the scenario, and they do a better job because they understand how the system is put together and how it works. So for me, I think I just try to find that balance of, am I getting also better as a person? Why am I doing this? I just ask that simple question, why? Why am I doing it this way? Is there a better way? And that forces me to go back in history and look at how people did things before. It forces me to ask other people, hey, I'm gonna be a bit vulnerable. Here's how I'm doing this. Is there a better way? Like something simple as a code review process. You know how much courage it takes to submit a PR? Because it's going to be judged by your peers, whether it's good or not. And I think that helps me recalibrate. So that's the goal for me, is just to make sure that I'm progressively getting better. And on the tech side, and being a person.
Andjelko, what's your approach?
Well, I think up to a point, it is a personal kind of direction or I guess maybe a decision to keep learning, right? Or not. Like you might reach a point in a career or in your like learning of technology or whatever and say, I'm good with this. This is my comfort level. I'm going to grow in a different direction from here on out. But even then, you're not stopping the learning process. So I think curiosity is part of human nature. We have it as kids, and I think we should keep it going. And the technology landscape is kind of an ideal place where we can keep that childhood curiosity alive because there's so many new things and new knowledge being created and generated and new things to learn every other day. Like you just open the news pages, the Hacker News, whatever, and there's new stuff. It's something somebody thought about something that you never did, and there's this creative like whirlpool, like sparks of new knowledge being generated all the time by humans, sometimes by LLMs, right? But that's kind of where I think it just pays to be open-minded, to absorb more of the world, basically, and I think that's the best we can do.
Yeah, we are an industry. We are working in an industry where, I mean, if I stopped learning, the first thing I learned, I would still be developing in PHP 3 something. Yeah. MySQL, or MySQL 3 something, 329, 330. Anyway, I was doing LAMP servers basically 25 years ago, something like that. And I would be there today if I did not want to learn and understand, okay, I have a web server, but how the client is getting connected to it. And that's how I started getting deeper and deeper and spent many years in networking and then switched to load balancing. Yeah, you have to learn. We are in industry, that's it. And you don't know where you're going to in the end.
We are a knowledge industry. I think that's one of our benefits. Because like if we were an industry making bricks, we would still be advancing, but like the brick baking tool set is like evolving at a very steady pace. Romans built bricks and we build bricks today, and the entire process is not that much different, right? Part of it is relying on like physical properties where you need to assemble materials, you need to work on the materials, and you can't change the physical properties of atoms and materials. But the knowledge builds upon itself, and by nature being ephemeral, there's no limit to how much knowledge we can generate, and therefore our pace of learning is not limited by physical constraints. So we can keep learning, we can keep generating more knowledge, and that's how our industry is so fast and keeps being so, I guess, exciting to be part of.
There's probably leaders in the audience, team leads, directors of engineering, VP of engineering. The one thing I advise a lot of people is just think about the ways that you kill curiosity in your company, in your team, right? Because everyone complains about their company being slow or something doesn't get fast enough. And you're probably part of the problem one way or another if you don't really think intently about how you kill it. Junior engineer comes in, what's perceived to be a dumb idea, but they're super excited, they're passionate, they're fired up. They want to try this thing out, and then you crush them. You say, we want to hire smart people, and then you just crush them. Just follow the Bill guide. It's mature enough. And there's a way you manage that type of person. It's very different than do exactly A, B, and C. I actually want you to think. And sometimes I got to give you a lane to swim in just so you can satisfy your own curiosity. And then I have to direct that energy back to something that we can put into production. But the way you manage that person, if you extinguish that, then you're just going to get somebody that comes in now, come in the morning, check for their assigned tickets, and do the bare minimum not to get fired. And then you try to repeat the process then. We got to find really good people that are motivated. Also, you can repeat the process when they join. This is a deliberate, like when you talk about the human interactions to all of this, what do you do specifically to cultivate someone that has that fire and avoid distinguishing it before they get going?
I think Baptiste, backstage, you gave me the real answer to this question, which is the way you change and stay up to date is by watching Hussein's YouTube channel.
Yeah.
Also, yeah.
Hussein, managing a large YouTube channel, you probably have to be more adaptable than most. How do you stay on top?
I have a little bit of a controversial take on this, and that is 4 letters: FOMO, fear of missing out. I have this problem because it seems to be the fashion that every week we have a new technology, a new this and that, and the more it gets buzzed in social media, the more I feel, oh, I have to learn this. And I would be careful with this, because if you follow random, tales, that eventually that thing will lead you to nowhere. So I tend to stick to the pure fundamentals. Like, I'm talking TCP, keep alive. I'm talking the basics of TLS. And you'll be surprised that by just trying to follow that, flame inside you and trying to learn just that, you will then open doors that, okay, I don't understand that. And then you'll try to learn the next piece. And this is what is called collateral knowledge, where to understand something, you have to kind of unlock that other piece. And that, naturally, you're just moving towards what you're passionate about, and then you're learning things. You're not consciously because you want to learn to get better, but naturally. And that's how my entire content is based on. You'll see that I'm excited about talking about something that has been shipped 10 years ago, or a post that Willie had posted 4 years ago. I would just, I really liked how HAProxy processed 2 million per request a second. I don't know how that is done. So I would just read it and then I will talk about it. It's old, technically, right? In internet, this is ages, right? 4 years ago. But I would just follow what I'm passionate about, and I think that's just a general advice to everyone.
Good advice.
Well, I'd like to say a huge thank you to the panelists. I know we're out of time. I feel like we could keep on talking for ages, but we'll have to wrap it up. I think we've all going to take away something really useful from this discussion. Let's give the panelists a big round of applause.